So the gravel is going up this conveyor belt, it dumps down, and then the pile turns out to be a cone. So it's got a round base, and then it's got a height which is perpendicular to the radius, which is in the base. And then we've got information such as the height and the diameter are always the same. So diameter would be 2 radii. So the height is equal to 2 r's. Okay, next is it's being dumped out at a rate of 40 cubic feet per minute. So this is a volume. So we need the formula for volume of a cone, which is 1/3 pi r squared times h, which is a really cool formula because pi r squared is the area of this base, and so you use 1/3 of the base and then go straight up from there. Anyway, that's just extra, no charge. So this is the derivative of the volume with respect to time. So often you can use the units to help you out. This is saying the change in the volume with respect to the change in time. How fast is the height? So this is saying how fast is the height changing with respect to time. So that's what's being asked for. And then this, when the h is 10 feet tall. So we need to take the derivative of this and then put in all this information. Well, since this has two variables, actually two variables on this side, I would need to use the product rule, but since this says I can replace an h with 2 r's, then I'm going to do that. Or I could replace, if I divide by 2, I could replace r with h over 2. And I'm actually going to do that because I want to have h in the function since this is about h and this is about h. I don't want to get rid of h. So instead get rid of the r, replace it with h over 2. So we've got volume equals 1/3 pi, and then it's got to be h. So let's see, this is going to be h squared, and another h makes h cubed. The denominator needs to be squared, so it's a 4. So we've really got 1/12. Now take the derivative with respect to time. It's going to be 1, actually pi 12ths. Can put the constants together. And then take the derivative of h cubed is 3h squared, and then times the derivative of h with respect to time. So implicit differentiation gives us an extra dh dt, which is a good thing because that's what we're supposed to be solving for. Now we should have numbers for everything else. So we've got h is going to be 10, and the change of the volume is going to be 40. Another thing you can do to make sure that you're doing things right is keep track of the units and then see if the answer is in the units that make sense. So when I look at the units, I've got feet cubed is going to get divided by feet squared, so it's just going to be feet. There's no other units, so minute is going to stay there. So it's going to be in feet per minute, and the height is a feet, time is a minute, so that's dh dt. Now I just need to move the numbers over. There was already a 40. I'm going to need to multiply by 12, and I'm going to need to divide by 100, 300 pi's. So we've got 40 times 12 that gets divided by 300 pies. And the height is changing at about half a foot per minute, which sounds reasonable. So 0.509 feet per minute is how fast the height is changing with respect to time.